Okay, welcome back. This is our fifth and final snow day video, and today we're moving into a slightly different realm. This is solving radical equations. So we're actually moving out of the realm of expressions for a moment, and we're jumping over to the realm of equations. Remember that algebra has three branches. So today we're going to be solving the radical equation. Okay, so the directions today are to solve, and this is pretty straightforward. You guys have solved absolute value equations, so I don't think you're going to find this difficult at all. If I write the square root of 3x minus 1, here let's do plus 8 is equal to 11. Okay, what you have to do here is first remember isolate. Okay, so just like absolute value, think of the radical as a unit. You have to isolate the radical. That means get rid of what? Get rid of the 8. Since 8 is being added, we're going to subtract 8 on the other side. So subtract 8, cross it out. Okay, and we're left with the square root of 3x minus 1 is equal to 11 minus 8 gives 3. Now that the radical is isolated, we have to check, is the right side positive? Is the right side positive? Yes. It's the same rule as absolute value. The right side must be positive. If the right side is negative, there is no solution. Okay, so all of these tonight have positive right sides. You don't have to worry about anything tonight. So the right side is positive. Now, we continue on our way. Okay, so we're going to look at we're going to look at no solution examples when you guys get back into class. But anyway, subtract the 8, we get a 3. And now how do we undo the radical? It's pretty simple. Put parentheses around both sides. How do we undo a square root? We square both sides, square both sides. When you square a square root, it cancels out, leaving just 3x minus 1 equals, and now square the 3. This is not 6, this is 3 times 3, which gives what? 9. Now, finish isolating x. So take the negative 1. Remember, we add first, so add 1. Cross out the 1, we get 3x equals 10. And now divide by 3. Divide by 3, we get x equals 10 over 3. And convert this to a mixed number, 3 and 1/3. And you are done. Okay, so next example. Next example, and we'll be done with this video very quickly. Okay, so we're looking at 3 times the square root of x minus 5 is equal to 12. Okay, so in this case, notice 3 is not being added, 3 is being multiplied. So again, we have to isolate our radical. That means get rid of what? Get rid of the 3. Since 3 is being multiplied, we do the opposite, divide by 3. Divide by 3, what happens? The 3's cancel, we're left with the square root of x minus 5 is equal to 12 divided by 3 is 4. Again, when you get back to class, we're going to investigate what happens when this is negative. The radical must equal a positive value. But since the 4 is positive, everything is good. And tonight, all of your problems have a positive right side when it's isolated. So when it's isolated, we always stop and check. Is the right side positive? Yes. So we continue on our way. This has a solution. How do we undo a square root? You put parentheses around both sides and you square a square root. This cancels out, leaving what? X minus 5 equals 4 squared. 4 squared is 16. And now to get rid of the subtract 5, just simply add 5. And you get x equals 21, and you are done. You can always check your answer. If x is 21, put it back in. What is 21 minus 5? Well, 21 minus 5 is 16. And what is the square root of 16? The square root of 16 is 4. And 4 times 3 would give 12. So you can always check your solution by putting it back into the original. Now, on the next two problems, you have cubed roots. So let's look at a couple examples. If we square a square root, what do you think we're going to do with a cubed root? Yes, we're going to cube it. So we're looking at cubed root of 4x minus 1 is equal to, say, plus 7 is equal to 10. Now, the first thing we have to do is isolate the root. That means get rid of the plus 7. Since 7 is being added, subtract 7. We get the cubed root of what? 4x minus 1 is equal to 10 minus 7 gives 3. Now, notice the radical is isolated. And I will just say this. With cubed root, it doesn't matter. Cubed root always has a solution. The right side does not have to be positive. I'm not going to get into that in the video. I just want you guys to be comfortable with what do we do to get rid of the cubed root. Now that it's isolated, we put parentheses around it and do what? If we square a square root, we will cube a cubed root. If you cube a cubed root, these cancel out, leaving just what's underneath. 4x minus 1 is equal to cubed 3. This is 3 times 3 times 3, which is what? 3 times 3 is 9 times 3 is 27. Now, we have to get rid of the 4 and the negative 1, start with the addition. 1 is being subtracted, so add 1. We get 4x equals what? 27 plus 1 is 28. Now divide by 4, you get x equals 7. And this is your final answer. You can always check it by putting 7 in. 4 times 7 is 28, minus 1 is 27. The cube root of 27 is 3. 3 plus 7 is 10. It all checks out. One more example. Like the last homework question, let's say you have 5 cube root of x minus 1 is equal to, say, 5. Okay, so how do we deal with this? Notice 5 is being multiplied out front. We have to isolate the radical. That means if 5 is being multiplied, we divide by 5. Divide by 5. What happens? The 5's cancel. You're left with the cube root of x minus 1 is equal to 5 divided by 5 is 1. And same thing. If we square a square root, we're going to cube a cube root. Put parentheses. Take it to the third power. Cube a cube root. These cancel. You're left with x minus 1 equals, well, 1 cubed is 1 times 1 times 1, which is just 1. Now, to get rid of the negative 1, just add 1. We get what? X equals 2. And you are done with this video. So congratulations, guys. You finished all 5. Just knock these homework problems out, and you guys are ready to come back to class. And hopefully I see you guys soon. All right, take care now.